Please see the last problem for the kind of like the full explanation of what this problem means. Let's see here, let me get a better x here. dx, we're dxing both sides. Now I'm going to get really tricky here and just dx the whole equation, which means the ddx of the left side equaling the ddx of the right side. I guess I just repeated myself there. But anyway, the derivative of, why are we doing this? Our goal is to find the slope. Okay, our goal is the slope equals what when x is -1 and y is 3, because that's what this says up here. We have this equation, we have a point on the particular curve, okay, and we want to find the slope of the tangent line at that point, because once we have the point, we just need the slope if we want to come up with the equation of the tangent line. So all the calculus does for us here is it helps us find the slope of the tangent line at that point. And throughout this entire assignment, we've been taking the derivative of both sides with respect to x, because the y is not, I should have a squared right there, shouldn't I? Because the y is not explicitly defined in terms of x, and so that's what made me catch that squared. I forgot to write a squared down here. So the derivative of this product is the first times the derivative of the second, which is 2y times y prime, plus the second times the derivative of the first with respect to x again, which is 2x, and then equaling the derivative of 9 with respect to x. Well, that's just 0. Okay, in the last I finished this whole thing and I realized that it wasn't recording me, so I'm not sure what I said in the beginning. So this is the work for the problem number 29. We already did problem 27. I know I did that one right, and you saw, you got my whole recording for that. But let me just review what I did here, and then hopefully if you watch the problem number 27 video, this one should be no problem, because really this problem is the exact same, other than it's a different curve, but exact same in that we're using calculus here to find the slope. This is the slope of the tangent line, and once we find the slope of the tangent line, we can use the point -1, 3, the coordinates of that point, and the slope to get the equation of the tangent line. So the equation of the tangent line is y minus 3, which is y minus y1, equals slope times x minus x1, x minus -1, which is x plus 1. Okay, and then up here in the upper right hand part of the screen, I said since the slope of the tangent line is 3, the slope of the normal line then has to be -1/3, negative reciprocals, and so therefore the equation of the normal line to the curve at the point is what you see here in the lower right hand part of the screen. Okay, so that takes care of homework number 71. I hope that helps, and keep in mind we have a test coming up, and you'll get a chance to show that you know how to do all these things. And if you have any special requests, please send me a message, and I will do my best to get another recording out so that you understand.